Hi, everyone. Kevin Clark here for People-Centered Internet and our bi-weekly community call. Today, I'm delighted to have David Smith with us. A little bit about David. He'll tell you a lot more about his background on his own as he goes through his presentation, his demonstration, his remarks. But he's the CTO and co-founder of Croquet Corporation, developing the Croquet web-based operating system. And, you know, I think about this as a, I don't know whether you would agree with this, David, but it's kind of like a smaller modular approach to metaverse, but he'll explain it. He's doing good work here. He's a computer scientist. He's a serial entrepreneur, and he's been focused on, you know, interactive 3D and using three-dimensional representation as the basis for new user environments in entertainment and human interaction. He built his first machine, interaction design in 1986 to study telepresence, control of a remote robot arm using a data glove. And I still hope to get telepresence into my home, you know, and as soon as the cost drops, it'll be any day now. All right, it's been decades in coming. So I have had the pleasure of working with David through some of his colleagues and collaborators here in the Research Triangle region. He kind of cross commutes between Silicon Valley and the Research Triangle region. And I was first introduced to him by Richard Boyd, who is a guest on the call today. He's the founder and CEO of both Tanja Machine Learning and Ultisim that has expertise in digital twins. So with that, David, I could say so much more about your background. I think you've got a great enthusiastic group of people who want to hear about Croquet and what it's capable of doing. So it's all yours. The format is going to be you present. Once you're done, we'll open up to Q&A. I'll be collecting Q&As in chat. And then we have at the bottom of the hour at 12:30 Eastern, we'll say thank you to those who need to depart. And then we go into overtime for a half hour for additional people who are really jazzed about the content. With that, David, it's all yours.
Fantastic. I'm going to try to share screen here. Hopefully that works. That one, share that. So you should see, hopefully, my first slide.
We do.
Awesome. Yeah. All right. Thank Kevin for giving me a little bit of intro. Yeah, it's true. I've been, I wouldn't say just focused. I've been obsessed with this idea of what I've been calling an augmented conversation, which is I think should be, especially in light of this group's history and awareness of where all the cool stuff we use every day actually came from. I don't have to explain too much about this to you, but I'm going to set the context of you know what we're doing and where that really came from. And like I said, there should not be a lot of surprises. I kind of look at it this way: study the past, if you will, divine the future. And you all are very aware of just how important that is. That was Confucius that said that. Much more recent was this quote: during the mechanical ages, we had extended our bodies in space. Today, after more than a century of electric technology, we extended our central nervous system itself in a global embrace, abolishing both space and time as far as our planet is concerned. This is like a quote from yesterday. It's actually Marshall McLuhan, 1964, in his book Understanding Media. The subtitle of that is extraordinarily important. This idea, he calls it the extensions of man, and in fact, it's extensions. We extend media, and media extends us. This concept of a global central nervous system, though, is something we all are intimately aware of, although we don't necessarily give it a term like that. Someone tweets a few milliseconds later, all of our brains are impacted, our consciousness has been extended into everyone's lives and theirs into ours. Not always a good thing. So the question I got posed, and we've been talking about this for well, decades really, is what's actually needed. This should not be a surprise that I think all good things come back, at least in the computer world, to Doug. And this, in particular, the key thing about all the world's big problems is they have to be dealt with collectively. If we don't get collectively smarter, we're doomed. This is more true today than ever, and something worth considering when we build any kind of system. Because say we're connected as consumers for sure. We share tweets, we email, we're doing a Zoom call right now, but we're not doing that as creators or problem solvers. They're not; these things aren't making us smarter. They're not addressing that challenge that Doug raised. Most people know Doug as guy who invented the mouse, but what he really did, he wanted to understand and construct the system of how humans would interact with computers, how they would use computers to interact with each other, and they use the computers, that system, to attempt to understand and solve hard problems. Computer was needed to provide a shared intellectual place for argument. An argument is really this idea of exploring and constructing of idea spaces. But that shared intellectual place really is the centerpiece of the work that we've been doing for these many decades. I'm not sure. I'm going to stop sharing for just a second because I think I didn't turn on the sound for that. So I'm going to stop sharing. And I'm going to start it again. Yeah, I'm okay. So I'm going to keep going. This is, I'm certain all of you have seen Doug's Mother of All Demos. That Mother of All Demos came many years later by Steve Levy, who coined that. But that's how we know it today. But this particular segment of it is very important to me because it illustrates a centerpiece of what Doug was doing. So I'm going to just play this.
And so this special thing, if I label 13, will switch over. So in his display, he sees my text. So I'll execute it. And sure enough, it does. But what's that running around? Well, if he's looking at my text, he'd like to have something to say about it. So we put on a marker, a tracking spot that he controls. So he's sitting there in Menlo Park looking at this text, and he can point to it. But we've carefully reserved for me the right to control and operate on this. So my bug is more powerful than yours. But we can have an argument. Yeah. That's what they call a bug fight. So, all right. So in case you haven't been listening, Bill, we've been going through lots of examples and setting up in collaboration here so that we can go on into information retrieval. And we've set up now audio coupling, and then we're both looking at the same display, and that'd be very handy to work. We can talk to each other and point, and maybe later I could hand you the chalk on this blackboard, like saying, here, you control it. But let's stay this mode now and add another feature that hardware-wise is available through the kind of display we have. I'd like to see you while I'm working on it. So before I can do that, I'd have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that'll bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work, you can point at it, and I can see your face, and we can talk. So let's do some collaborating.
If you haven't seen that video, which is all over the place on YouTube, certainly go see that. But I think you all see that, and if you're familiar with Doug's work and NLS, which I'm assuming most of you are, you'll understand the extraordinary importance of even that little segment, which illustrated so many instantaneous things, and particularly the idea of collaboration, and of course, what we're doing right now, which is video sharing. But the real power of the system was that they used the system not just like we're doing right now, we're remote, but if you see this picture to the side, they were using it. They were using it as a tool to extend the way they engaged with each other, even when they're sitting side by side. And so he had this concept of a collective IQ, which is a measure of how well people work together on these important challenges. Ultimately, it was a measure of effectiveness. And think about that. It's like he wasn't just designing a system, he was designing a process, and a meta process that allowed him to modify that system to continuously improve it. This is a kind of what he referred to as bootstrapping, where you have a state of technology enables us to more easily, more capably manipulate information, which then allows us to improve the safe technology, and then again improves our ability to manipulate information. So this ability to manipulate information leads, at least led me directly to this Alan Kay, who I've been working with for over 30 years now. This is my favorite quote of his, by the way. Man is much more than a tool builder. He is an inventor of universes. And I think that's just such a profound and correct thing, particularly in this age of what we're looking at as the metaverse. But this is an important concept. Alan, this about to say about how to think about computing, and it's not that writing in the press made possible a very different kind of travel through time and space, but that a new manner of traveling through ideas was a consequence of what it meant to learn to read and write fluently. And of course, he's applying this read and write fluently, not just to the historical artifact of us reading books and things, but looking at computer systems as the things that we are now learning how to read and write and engage with. That idea space led to this device. This picture was drawn by Alan on a trip back from visiting Seymour Papert, where he was introduced to Logo. And by the way, obviously Alan knew Doug and his team very well as a graduate student. He spent quite a bit of time at Doug's lab. And so when you look at this picture, you're seeing a lot of influences. You're seeing Papert with Logo and the ability for children to express and control ideas, but you're also seeing Doug's vision of collaboration. If you read the paper reference here, A Personal Computer for Children of All Ages, came out in 1972, you'll understand, first of all, look at their screens. They're actually playing Space War together. But in the paper, they transition from playing Space War to modifying the program itself collaboratively, switching back and playing again. They basically add a black hole in the middle or something, or a sun. And so the concept here was, this was not just this is not Game Boy. This is a communication collaboration platform of the same mold of we just saw with Doug. And here was a prototype made out of cardboard that illustrated kind of how it would feel, how it could look. And of course, if you've seen an iPad, you have a pretty good sense of at least the look of it, but nowhere near the power. This is Smalltalk that when they created it, they considered it to be the interim Dynabook. The way that the humans engaged with this system was really crucial and extraordinarily powerful, and a number of key capabilities associated with this. I'm going to let me see if I have that next slide. Yeah, the Alto had a very, very, very powerful capability. I had many, but one of the most important ones is almost the entire software system could be modified by the system itself while the computer was running. this is an organic kind of programming. It's like you have an idea, and basically you have this electronic modeling clay that allows you to modify the system using the system and extending that system. This, by the way, really leads back to Doug's idea of bootstrapping. You're using the system to extend the system itself. This is hard to believe, but this doesn't happen today. You don't have live programming environments except for Smalltalk, which is still there, of course. Lisp also has it, but for the most part, we don't live in that world. And particularly when we start thinking of collaborative systems, this is a big hole. This is Steve Jobs talking about his getting to see the Alto for the first time. Dan Ingalls was the person who actually gave him the demo. I'll let Steve speak a little bit about what he saw.
And they showed me really three things. But I was so blinded by the first one that I didn't even really see the other two. One of the things they showed me was object-oriented programming. They showed me that, but I didn't even see that. The other one they showed me was really a networked computer system. They had over 100 Alto computers, all networked, using email, et cetera, et cetera. I didn't even see that. I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I'd ever seen in my life. Now, remember, it was very flawed. What we saw was incomplete. They'd done a bunch of things wrong, but we didn't know that at the time. It's still, though, they had the germ of the idea was there, and they'd done it very well. And within, 10 minutes, it was obvious to me that all computers would work like this.
And indeed they do, and every phone does. What Alan actually said that they showed him 10 ideas, not 3, and he missed them all. In fact, a really important one, Dan was doing the demo, and the programming text was scrolling line by line, which programmers might have liked at that time. And Steve said, that's wrong, and it has to be a smooth scroll. So Dan basically opened up the code browser, removed a line, which was to quantize the steps, and switched back, and it was smooth scrolling. The fact that Steve didn't see that action as a center point of what was possible, the very idea of modifying the system while it was running to change its behavior of the exact thing you're touching. It's like he was touching the code and it was modifying how the code worked. The coding worked was fantastic and totally invisible. By the way, all good user interfaces are invisible. So that's in a way not surprising. It did what it was expected. And when that happens, you don't see it anymore. So both Doug and Alan understood the computer as a medium, but in particular a live medium. That leads to this concept, which is really just kind of Doug's vision with maybe a little more updated, but I call it the augmented conversation. And I see it as a primary factor in how human-computer interfaces. Let's back up. The original creators of the systems we use today, the original visionaries, really saw the computer as a full partner in what I'm calling augmented conversation. What happened, though, and it's an artifact of history, that Doug's vision, in a sense, did not survive Xerox PARC. What got missing was the other humans, that liveness between people on the same system. Doug had a time-sharing system, and when transitioned to personal computing, the idea of having computers collaborate in that same way proved to be extraordinarily difficult. But augmented conversation allows us to jointly invent, explore new universes, going back to Alan's quote. And I'm going to talk a little bit about what this is. Augmented conversations features are a discussion within a group of users that is extraordinarily enhanced with the kinds of tools and capabilities that are only available with a computer. That's definitely Doug. Another very important one which Doug didn't have available. A computer AI is a full participant in this conversation. It allows us to jointly discuss and explore complex systems, data sets, and simulations. As naturally as we talk about the weather, and that's, I'm serious, you're going to be able to describe something in this conversation. The computer is going to generate simulations of that. We're seeing this today. You know, you see DALL-E as a first order exemplar of what we're talking about. It's going to be far more sophisticated than that. But and then the third is there has to be a guarantee of shared truth. The simulation I see must be exactly the same as what you see. And anything I do to touch and interact and affect that shared simulation must be also accurately shared. If in a communication, the message I'm sending is not the message you're receiving, then you're not in a position to trust that communication channel. So it's essential that this shared simulation be exactly the same for us. It has to evolve in exactly the same way. And that was one of the problems that we wanted to address. And then, and this is kind of how it has to work. The shared system must enable bit identical modification extension of that system while it is running live by all participants, just like what Doug showed, just like what I talked about with Smalltalk, a living system. We have to be able to use the system itself to extend the system, to prove it, and add new capabilities. And that's why we create Croquet. Augmented Conversation requires a new kind of operating system. It's got to be built up from the ground up, emphasizing this perfectly replicated shared simulation and also deep security. You just can't add these capabilities as a layer on top of a system. It has to be implicit throughout. And by the way, even programming and debugging have to be fully collaborative interactions between users. And we built that to do this. The Croquet protocol is a dynamic, immediate, perfectly synchronized, even complex simulations are shared with no need to communicate state between peers. And that sounds wild and weird, but in fact, that's true. We kind of consider it to be a missing protocol of the internet. We believe it redefines collaboration as the classical internet protocol based upon end-to-end principle. And we is this. This is the team that created the system, and you're probably familiar with some of these guys. Obviously, I was just talking about Alan. David Reed was basically sort of the center of how this would get done. His thesis was this idea of replicate computation for naming and that sort of thing. And so that was the basis, the foundation of the system. And a lot of you probably know David, certainly know of him. He was the designer of UDP, and he was certainly, Alan calls him the slash and TCP/IP, because he's the one who figured out that TCP should be on top of IP instead of as a separate protocol. Andreas Raab was our peer working with Alan on, he was one of the main developers of the Squeak language. And this is an illustration of how the system works. User interacts. It's a model view architecture, if you're familiar with that, but basically the model is the replicated deterministic state engine that's also local to the user. The view is what you see. It's an interpretation of that. When a user interacts with that view, touches it or whatever, instead of the message going directly to this shared virtual computer, message goes up to an edge reflector, which is someplace out there, could be on a 5G network. That puts, all that does is adds a timestamp to that message, and then that message is distributed to all the virtual computers, which then compute that message as part of a stream of messages. And what happens is that virtual computers always stays in sync without having to communicate between each other, which means that the bandwidth requirements are extraordinarily low. Even random numbers are replicated like this. So what I'm going to do is switch over and give you a demo of this stuff, because it's kind of meaningless without that. This is Croquet. I think you can see this. And what you're looking at is two users. To give you an idea, as I move this guy forward and back, you can see one guy sees it. I'm controlling two users. Normally I open this up and have everybody part. I'm sorry. I have a bounce. Okay. Anyway, what I'm going to do, because I have two users, I'm actually going to go into presentation mode and bring them both to the same guy. So now this is synchronized. And the reason I'm doing that is, I'll go over here. This is an example of a simple bit identical shared state. I can grab this and move this around on one machine. And by the way, both are running locally, but it doesn't matter. We're running off of a reflector out on the cloud somewhere. It's still pretty close, but and I might also mention, we took a page out of Bill Atkinson's book. This is everything inside here is a card, like HyperCard. So there's cards and behaviors. Cards are the 3D things you see. They don't have to be flat. And then behaviors are the code associated with that. So as an example, I can, let's see, I think I can do this. Or let me, yeah, this should work. There. Oh, that's working. I don't know why I can't drag it. But anyway, I'll keep going. Over here, we actually have a PDF viewer. And as you notice, as I scroll through this, this is our presentation for Croquet. Here's that same image I was showing you later. But I'm going to keep going. Over here, this is actually live Bitcoin data. We're looking at data from Coinbase that's being displayed. And this is actually a deck of cards. At the bottom is a card that's grabbing the data. And then on top of it is a bar graph that doesn't know anything about Bitcoin. It's just basically listening to value changes on the underlying card and plotting those. And you notice that when the value goes up, it goes green, and that top left corner Bitcoin logo is just another card that's listening to color changes. When it goes up, it goes green, and when it goes down like it just did, it goes red. But one of the things about these metaverses, and you're looking at our vision of what the metaverse should be, is that you should be able to connect worlds together. And one of the things I did years ago is I invented a thing called portals. And a portal in this case is a link between two worlds. And we're looking at, actually, this is also a card. And even though I can spin this around, as you can see. And what we're going to do, the way I think I can do this. Hold on. What we're really looking at is two iframes using a thing called multiplane portals. This is very similar to the invention by Disney to do Snow White when they did that. And so I just flipped these two on their sides, and so you actually are looking at two different iframes. And what happens when I walk from one space to another, you can see we're actually changing. We're changing that hole in the top one, so that what it sees on the other side is, more or less. And then I walk through and watch this. Those portals, hopefully, they should have changed order. Oh well, it didn't. I'm gonna close this, and oh, I know why it didn't change order, because I didn't have it open on the other side. I don't have it open on this side, but it did the right thing. So over here we have controls. All this stuff is just programs, little behaviors running in the background, including control of that robotic hoist there. I'm going to open this up. And this is where it gets pretty interesting, because what we're now looking at is perfectly shared simulations of a much more sophisticated sort. We have this drone here. And what I'm going to do is tap him. And then I'm going to open up let's see, I hope I can do this. Oh, it's not working. Oh, let's try it on this one. Oh, it's broken. That sucks. Well, I can't show you that, but I'm going to have them fly again. There's a really cool part of this that unfortunately we'll miss. Gonna do that. So what I'm going to do, this is the actual code of that drone that controls that drone. And I'm going to jump into this so you can see a little better. What we have here is, you see this toggle function. What we did was we added an event listener, a pointer down event, that when a pointer down, when you touch that drone, it calls toggle. Toggle is that if this is circling, stop circling. But when it's running, we could do that little classic logo trick. We rotate a little bit and move forward a little bit, which is the kind of the recipe for a circle. And what I'm going to do is I can actually modify that code dynamically. And when he comes around again, what we'll do is I'm going to compile that, and he goes in a different direction. And why that was interesting is that was a shared that's shared code. I was able to modify the system dynamically for both those worlds and any other participant. In other words, we're able to do what Dan Ingalls was doing with Steve Jobs, but we're able to do it collaboratively. All of us are able to engage with this at the same time. Over here, we have this globe is actually displaying most of the current flights, commercial flights in the air right now. Every one of these dots is updated within at most a minute or so. So as I spin this, you'll notice something really interesting. This very stark area at the top of the globe, that's Ukraine, where you'd expect that there wouldn't be a lot of airplanes at the moment, at least commercial airplanes. And then moving over to here, what we have is a perfectly synchronized physics simulation. And I really have to emphasize here, they were not communicating any state between these worlds. The system is fully deterministic. What it does is takes a snapshot every 5 seconds of compute time. So when a new user joins, they can grab that snapshot and play back all the messages that they missed. And so they'd be caught up. So, but the reality is this simulation's running side by side, and it could be just as easily running on your computer as it is on mine. And it's running a bit identical, even randoms are identical. Even transcendentals are identicals because we had to patch that. But everything inside these worlds is perfectly shared. And by the way, I've been running as two people. I can kind of break away just to show that it really is indeed multiple users. But I'm going to switch back to this because I'm kind of, this is the similar. To sum up, Alan has these extraordinary quotes, as you know. This is one of my favorite. The computer is an instrument whose music is ideas. And I thought, well, if that's the case, augmented conversation is jazz, where we are working together to create something new every time. And once you understand all of this, once you see this kind of approach to what computing really is and should be, then you understand that the metaverse is really a communication medium. Our ability, when I talk about augmented conversation, that's really the center of what the metaverse can be and needs to be. And that's why we consider this so really important, because we're kind of this crossroads. So many people think of this metaverse thing as, oh, that's the next big consumer thing in the sky, and certainly will be that, but that's not going to be the thing that helps us as humans, in particular solving some of the existential issues that we face. We have to really to start building tools that will allow us to start thinking better and understanding better, and certainly the work that Doug did and the work that Alan did pointed the way towards that. And but that's an unfinished journey. And that's it. Thank you. And I'm open to questions.
Well, thank you, David. Greatly appreciate a quick unpack of what you're up to right now with Croquet. I certainly understand it differently now that I have, seen this perspective. We had quite a few comments, so we're going to open up to Q&A now. And as I'll remind you, we'll go to 12:30 Eastern time, and then for those of you who want to stay with us, we'll go into overtime comments and questions. So Maylin, a lot of connectivity here. You chimed in first, and it seems that you and David share some experiences. So please.
I'm delighted to see how much you have done, David. This is such a difficult area because
You're telling me. But such an important one too, right? I mean, I think that I said earlier, I was obsessed with this. And I'm not the only one. I mean, Doug, sort of this maybe heresy, but Doug was very messianic and needed to be. I mean, his concepts, his story was so very, very important. But yeah, I mean, it's like there's a lot of wilderness there. And I alluded to a story about what happened, how kind of Xerox PARC stopped that effort, not intentionally, by the way. I mean, if you probably remember that a lot of Doug's team got hired to Xerox to continue that work and build the next version of NLS, which was called Polos. And so they were actually building that on yet another time sharing system, which is Xerox's in this case. But what happened was the Xerox Alto shows up, and it took all of the energy out of. And I don't know if we're aware of this, but you actually had to go down to the basement of the lab to build your own. And of course, everybody did. And the thing was just so extraordinarily interesting that no one went back into the Polos room. That project basically died because this new machine showed up that was so extraordinarily interesting. The problem, though, was, as I mentioned, is that no one knew how to do collaboration on the personal computer. They had Ethernet, so they could share files, they could share text. This idea of doing instantaneous updates, like the stuff I was just showing you, wasn't possible. And so we have seen that we paid a very heavy price for that. And even today, and that's so I'd say that Doug and Alan both. I mean, they both had that same vision. Alan was trying to carry it on. And I think one of his, in fact, I know he felt one of his failures at Xerox was that half of the mission of creating true collaborative infrastructure didn't happen, which is one of the reasons I think he and I wound up working together for so long was maybe try to fix that problem. I didn't answer your question. I didn't hear it. I'm sorry.
it's okay. I just want to make a couple of comments about that. So Doug, really, it was the most devastating event of his life to have his team basically abandon him at SRI and go to Xerox PARC. He knew the dangers for humanity. He said, if you go to Xerox PARC, you will do personal computing, and it will be a false branch where we can't get to collective computing. If you distribute it completely personal, you can't get back. So that's reinforcing what you've done, which is having to set up a whole new operating system.
That's right.
Whole different approach to continue the collective intelligence. So Doug went on to he left SRI and went to timeshare.
Yeah.
and then timeshare was acquired by McDonnell Douglas, and that actually gave him a new lease of life looking at the B2B space, because McDonnell Douglas had about 40,000 suppliers, and he began to apply his ideas to the enterprise B2B space. I found that some of the most interesting stuff that really has
That's
not
right.
been picked up.
I couldn't agree more. It's also the most sophisticated. I think his earlier work, you look at the mother old demos, I understand that. But then when he gets into these meta levels on the corporate side, that's first of all very powerful, but also harder to understand, which is I think one of the reasons it really hasn't been acknowledged to the extent it needs to be. It's a little harder to explain, and I'm not going to try, but you know what I mean.
So this is my last comment. So we at PCI were inspired by Doug's work because I chaired his core planning committee from 1999 to 2004 and helped to organize the program for the future, which is the 40th anniversary of the mother of all demos, and his memorial in 2013 when he passed away. So our effort now is in two directions. On the Tribal Resource Center, where we're looking at the collective community and building resilient communities, but behind that, the sort of background is the future of digital finance that is informed by the idea of building resilient communities. So we are taking a different approach than you. We are looking at the sort of engine behind the human operating system, both the legal and financial frameworks that will allow us to make progress. And we're finally looking at possibly doing something in Kenya and in Puerto Rico along those lines. A different approach to the metaverse.
Oh yeah, and I think it's all one at the end. I mean, I think there are all these. We're about to. I think of it almost as a renaissance, an opportunity for a renaissance, I should say, because I think we're going to see a convergence of a lot of ideas from the past that are finally acknowledged for the value that they had, and what you're doing and what I'm doing. I mean, it's like there's this new context, a new shift in the way people are thinking about what computing is, and which means there's huge opportunity to establish new foundations for this, rather than trying to continuously build on the old stuff. I mean, I know people are like, "Oh, I'm going to build a metaverse OS on top of Android." It's like, no, you're not. You're not. You might think you're going to do that, but that's just like that's, as they like to say, putting lipstick on a pig. That's not going to happen. That's not what the problem space is. That solves a completely different thing. And so yeah, I think this is one of the reasons it's been so exciting for us lately. But yeah, the other side of it is we've been working on this. I personally been working. The first demo I did of this stuff was 1994. But Alan and I started talking about it around 1990, about in just these terms, and of course, I spent many conversations with Doug, and that was a very interesting challenge there, because the things I showed you and showed him, that was this complete mismatch to his vision how these things should work. I mean, I saw it the same because underneath it was the same, but he had a very, very different worldview. But it was very, on the other side of it, though, is this system exists because of him, as you can imagine. It was like his vision permeates the thing from beginning to end. I feel extraordinarily lucky to have had opportunity to, even argue with him.
Thank you for your work and your dedication.
Well, thank you all.
Leland, thank you very much for that, and for your joint connection to Douglas and sharing that today. Richard Boyd had some comments and questions. He was next. Richard, join us.
Hey, good morning. Yeah, as you pointed out, David and I have been tilting at these windmills for about 30 years. My whole career has been just following his vision. So I'm happy to see him sharing ideas with all of you guys. But as we see this whole all these concepts around the metaverse emerging suddenly in digital twins, of course, many of us, like all of you, probably feel the same. That yeah, we've seen this train come by a couple of times. The question for you, David, right now is, and I know we've talked about this privately, but for this group, what is different about now than when we first started trying to do this with VRML in '95 and other ages before that, or since then, and who's getting it right out there and who's getting it dramatically wrong? And this is what's your term, Kevin? Like Chatham House rules, so we're not going to share it outside of here, but so
Oh,
feel
I'm
free to.
not, I don't care if you share it.
No, I didn't think you did.
We are recording this, so inside the community, we'll
Oh,
have.
I wouldn't mind, I wouldn't mind having it posted outside. so-
Well, there you go.
There, wow, why is it different? Well, let's put it this way first. We're not sure it is. It may well be that, oh, we tried again. I think it is different though, for a number of key reasons. One is the technological foundation required. And by the way, there's a number of pieces, components to this that we can point to. For example, when we talk about head wearable devices, I think they're a very important part of this. When I think of an augmented conversation, imagine glasses like what I'm wearing right now. I'm talking to you. You might be local, you might be remote. And I say something that generates this simulation of this object, and both of us are interacting with it. And I see that coming. And I think that technologically, we've removed a lot of the barriers to enable that. Particularly, look at smartphones. It was Mark Bolas who realized that smartphones were kind of everything you needed for a true VR device. And Palmer Luckey, by the way, was working for Mark in his lab, and so Palmer took Mark's ideas, created this little company called Oculus that turned into this other thing. But I mean, the conceptual model there, the phone can do in terms of its relationship to the world is exactly the kind of infrastructure capabilities you need for the kind of a live engagement like I was just talking about. Is that essential? I don't know about that. I think it's a very important part of the system, but the fact that the phone is so flexible, the tablets are so flexible, means that at least these ideas are going to survive in that context. I don't think they'll be quite as rich and capable until they actually make a transition to an always-on system. And in a sense, that's what we're looking at as an operating system for an always-on, continuously evolving platform. So why now? Technology has kind of reached a point where it's almost good enough. And then more importantly, people with lots of money believe it.
Yeah.
So you've got Apple investing billions, you've got Meta investing billions. There are many, many, many hard problems to solve here. But at least the dimension of usability of the system itself, the hardware, I think those barriers are dropping. The part that people aren't paying attention to is, like I said, as soon as you position the metaverse as a communication platform, that really should inform the rest of the work. And I don't think people have seen that yet. And that's why I think there's, first of all, an opening for an OS like what we're building. But the other side is you have to understand too, that if the metaverse is a communication platform, then you have to sort of think of it as your phone. You pick it up right now and you dial a random number, you're going to reach somebody. And you have no idea what brand phone. It's like every phone can talk to every other phone on the planet right now. So this plain old telephone service that exists on every phone really informs the nature of what the metaverse communication capability needs to be, which is that every metaverse device, every wearable device we see, think about in the future, and every handheld device should also communicate and collaborate. What that leads directly to, by the way, is that the web is the center of the world. It already is, but it's going to be the center of the metaverse as well, because every one of these devices is going to have a web browser. And so the web browser becomes the POTS of the next generation, which ensures then that when I have my Apple device and I'm talking to you on your Meta device, we'll be able to collaborate. And then a third person joins with a Google device and they're able to join instantly. Because that's the way it has to work. And there's no question to me that it will work that way. But the vehicle is going to be the browser. And then over time, as you know, the browser, this is classic Clayton Christensen, the browser is not as fast as native. But the capabilities that the browser has that native doesn't are extraordinary. That instantaneous access. Just basically every world is just a web page in a sense. You can connect these together instantly. You can move from one to the other. And the other thing is the browser is getting fast and faster all the time. That physics engine I showed you is running in WebAssembly. It's written in Rust. So we're getting closer to native performance. We're looking at web GPUs, the next generation of graphics, which gives us a 10x increase, not across the board, but in a lot of places. So you're going to start seeing that the browser is going to get as capable as native applications in some dimensions, but it maintains all these additional dimensions that are so much more important. So it's obviously, at the end of the day, when you think about what is the OS, the metaverse, it's clearly the browser.
So David, we have some other people who have questions. I want to just interject. There was an invocation that this might be Chatham House rules. It's not, okay? We would very much like to be able to feature this on the PCI website. We're working on our library of previous recordings, but I think this has been rich. Maylin agrees. So if you're okay,
yeah,
we'd like to give this a more additional visibility to others.
That'd be wonderful because I could use it that way. I go look at this so I don't have to give the talk again.
Well, okay, verbal consent granted. I love it. Okay. David, you were a frequent contributor in chat. Please join us.
Oh, hey there, David. I really, really enjoy the perspective that you're bringing to this. And I'm working on something that may underneath be very similar, but more for the web.
Yep.
And my question, and it's something that I've just been struggling with for a while, is does anyone care about collective IQ, especially people who have power? And also, do you believe that increasing collective IQ can actually allow us to transcend these really self-oriented systems that have been set up that work against the collective?
I'll answer the second one first. I have no idea. There's one of the things you're going to see, and this is a very dangerous thing, is that AIs are being taught to entertain us, and I suspect they're going to get very good at it. And so what that means then, it's going to be very easy to sort of sit back and watch the world unfold and on fire in front of you. I do believe, though, that although the vast majority of people may not take an interest in this, I sort of think we're in this really interesting phase. Let me answer one other question. A part of this is that part of the problem of whether people are going to pick up this collective intelligence tools for collective intelligence, we really haven't had them before. We kind of had the beginnings. We're sort of seeing certainly collaboration, things like Google Docs or Figma, but we haven't had kind of what anywhere near the ideas that Doug was presenting as something that was available, readily available. There's also a slight aside here, is that, you know, Alan's vision of computing was make stuff that's accessible as quickly as possible. Doug's vision was, it's like a car. A car is a very complex thing. You know, you spend you know, months learning how to drive a car. Why? Because you want to. But you know, it's like the two. You need both. You need kind of this accessibility, but you also need this extraordinarily strong desire. And I sort of feel like if you build the system in the right way, magic will happen. I'll give an example. There's well over 45 million children who use Scratch regularly, right? And of course, you know, Scratch came from Alan's group, created eToys, and so Scratch was kind of I'd say basically a simplified version of eToys. But that really shows that people want that power, that control. And so I think if it's presented properly, delivered properly, it has a chance. But the other more important thing was that, and I sort of feel like we're talking about existential issues here, or we should be, I guess. And certainly Doug saw it that way. And that part of our task here is, even though I don't think any of us are going to be the people who solve global warming as a problem, as an example, we are the people who are building tools for the people who will be solving those problems. And they need much better tools than they have today. A good example is the physicists before World War II understood that there's a big issue coming up, a big challenge to humanity coming up. And so they started understanding and trying to kind of formulate ideas around the solutions of how to, in this case, build the bomb. Whether you like it or not, that was still you know, kind of considered to be an existential situation. And so they looked at it. They had to create tools, technologies, put together ideas, and they started well before the Manhattan Project did. In fact, well, Leslie Grove, who ran that project on the operational side, went around and asking, you know, how would I build the bomb? And he got basically 86 different approaches. And of course, in a situation like that, what do? Well, if you're the United States government, you do all of them, which is what he did. And that's kind of what we're going to see here. I think we're going to have this is, you know, we're about to have our Pearl Harbor soon. And we're going to say, oh shit, we got to take this seriously. And that means we're going to have tools, technologies, capabilities that directly address what Doug's alarm was. So since what we want to be able to do is provide, you know, this capability, whether people think of it as, whether they see it as commercial or not, doesn't matter. It has to exist. And the other side of it is, boy, this stuff is empowering. Just like Scratch is. Scratch is this magical thing that kids can do. Can you imagine how powerful you are when you're a programmer and you're 10 years old and you're building stuff, you're exploring, you're doing this reading and writing through this new idea space that Alan was talking about. That I sort of say, this is real. I think we have this big opportunity to I sort of see it, get it back on track to where Doug would have liked to have seen it. It doesn't quite look like what he imagined, for better or worse, in our opinion. And you know, this may not be the right thing either, but you have to, Doug did 100 different kinds of user interfaces before he decided that the mouse was optimal. And so you have to build these things, try them out, learn from them, because they're the things that inform you of the right thing. The fact that this is our 5th iteration is kind of a good example of what I mean there. The first one was terrible, but taught me that how this terrible thing needed to be addressed. That's why we brought in David Reed, who had this idea of replicate computation. And again, that was great, except later on I realized that a monolithic approach is not going to scale and is very hard to manage, which has led to the model view architecture that I talked about. And it's like every one of these steps taught us what was wrong and what was needed. And but this time I think we've got it. I like to put it this way: it's, as Alan says, good enough to criticize, and of course, that's an important place to be.
Yeah, thank you.
Yeah. All right. So we are approaching the bottom of the hour, and we're about to go into our overtime session. Casey, are you with us?
Yep, right here.
Yeah. If you would, tell us about our upcoming speaker in 2 weeks. It's a return performance.
There's a redo. We have one of our fellows, her name, oh my gosh, Tiffany Brar. She is our fellow for the blind and seeing impaired. She tried to present, about a couple months ago. We had severe technical difficulties between connection and sound. There was a party going on next door. It was Mother's Day. So we're giving her a redo, and she's very excited to represent her program and what she's been doing. Very successful.
Yeah, just the fragments of what we heard told us that we needed to hear it in its entirety, right, in full fidelity. So
absolutely,
we're looking forward to having her contributions. I'm a big supporter of universal design and design principles at that time. All right, David, are you game for staying with us for another half hour?
More than happy.
Outstanding.
Whatever you like.
So a couple of things. I have a stack. Divya, Ben, Bruce, and Benita. I know you have questions. We're going to kick off this session because Maylin had something she wanted to pursue with David. So Maylin, if you'll come back in with the question that you wanted to pursue.
So you had a little throwaway phrase, and I wanted to pick it up in the non-recorded time. So Casey, could you stop recording?
Just pause recording.
For Divya, we would be grateful to have you join us.
Oh, hey there. I feel like the conversation's gone in a different direction. The only interesting thing to me is this conversation about distributed and augmented computing power. Has a lot of parallels to the brain and neural networks. And
Yep.
for those of us in the community who study consciousness and actually in human brains or in animal brains, there are just a lot of parallels in terms of the way we now define consciousness by some of the observed characteristics between brains that are, say, expressing enhanced or depressed consciousness levels. And that has a lot to do with actually functional connectivity, an increase and decrease in computing power and complexity, which we recently characterized in a paper we wrote. So that was the only thing I wanted to add.
Cool.
Okay.
Yeah, I'd like to see that paper. I think that's a really interesting perspective on this.
Yeah, I'd be happy to pass it along. In fact, we, I work in the operating room and I mount brains, using EEG, and we were able to demonstrate that brains, if you treat the brain as a dynamical system in terms of whatever state it exists in, if you were to trace out the time series of that EEG signal and plot it in a three-dimensional space using a time shift of about 4 milliseconds, you can trace out shapes that look almost like chaotic attractors. And when brains are awake and aware, they express almost this spheroid-like attractor, which to me implies a sort of multi-potentiality. And as the patient gets drowsier and then eventually becomes anesthetized, that chaotic attractor changes shape and it becomes somewhat cigar-like and then pencil-like, and then it almost collapses into something that looks more like a singularity. and then it moves back. And there's hysteresis too. So building out the network and contracting it are actually not parallel processes.
Very interesting.
Yeah, it is.
Yeah,
Interesting.
that sounds like a lot of fun to read.
Lynn suggested that you post a link to your paper in the chat.
Oh, sure. Let me see if I can find it online. I'll do that. Sure. Thanks.
We'd be grateful. And next, Ben Kosinski.
Yeah, I don't mean to take a lot of time. I just wanted to raise the thought that was triggered to me by my dog, who's has a whole different perspective on listening. And as we talk about a shared truth, and it always bothers me that there's a perceived notion of a universal truth. There is a canonical representation that might be shareable, but it might not be interpreted the same in different elements. And I look at in the case you're talking about moving in different worlds and rooms and cards, that there might be different physics in each of those. So a simple form might be physics that conflict in interpretation of what that shared truth might be. And so we have to tolerate a lot of complexity as we move forward, not just perceive a simplicity of a shareable truth that's enforceable, compliant, and so forth.
That's right. My goal isn't to be, how we put it, reality doesn't matter in this. I mean, you can see we do these 3D worlds, and that's to give people context, but I find that a little distasteful to me, that these are information spaces, idea spaces, and putting them in the context of here's a gallery or here's a factory is like kind of a waste. I mean, there's a need for it in certain situations, which happens to be a lot of our customers are interested in the digital twins. But when you get right down to it, what you really want are far more abstract engagements that you have kind of the ability to control and manipulate and understand. So that means that by definition, the physics itself is a simulation and is as malleable as anything else inside of this. I mean, I flip a sine bit and the physics is going to change direction. The gravity is now on the ceiling. That's how it should work. I think that part, that these are in environments that are designed for you to explore that simulation space, not just be a victim of it.
Very good. Thanks, Ben. Greatly appreciate that question. Next, Bruce, glad to have you contributing in chat. Why don't you jump in?
Yes. I've just been thinking about and working with some other folks on the idea of this idea space, as David's talking about, as an elaboration or an extension of this physical space model that we've been looking at. Idea space is a little harder to look at. And augmenting collective intelligence consisting of the ability, of course, to work in this idea space and if you think about collective, what does that mean? It's building a network of people and having it be a welcoming network that brings people, suggests people, tracks ideas as this network is doing its work, so that there's the evolution of ideas toward solutions, starting with just imagining and having this network space be able to configure around attractive ideas and have an part of the support for that would be identifying themes of conversations, whether they be verbal ones like these or emails on the side. The members of this collective community are enabled and supported and nurtured by the an AI system that's kind of tracking and understanding things and presenting ideas that it, like themes, for instance, proposed themes, so that the work of the group continues to advance and goes quicker because somebody's acting as a curator. And I visualize an AI system able to work across a large network of people in a way that one person might have a difficult time doing, to foster the arrival of nodes in the network and the evolution of the connections between people based on what's happening, based on suggestions and ideas, and moving it from fantasizing what could we work on or what would move things forward into project areas, into collecting subgroups that work on things and come up with advancements that then become available to the entire community and help the thing move along. That's, to me, that's the word of this augmenting of collective intelligence.
Yeah, I mean, I remember that part of the goal, I see what we're doing is priming the pump in that regard.
Mhm.
We have to get enough of the infrastructure working so
Right.
that the system itself can evolve. I mean, it's like, yeah, you say, oh, this is how it works. It's like, no, this isn't a thing we're talking about. This is a process.
Right.
And the first piece of the process is enable people to modify the process.
Right.
Mhm.
Right. So they can work on that. This augmentation itself is the first project of the augmented collective intelligence. Let's get a bunch of people to make this
That's
tool or this facility or this guide and curator available and starting to work. And it can be evolving because the group is working on that. And that thing is helping us to work together and advance the ideas and advance the solutions. And then that becomes a tool that can be used. You pick the problem you want to work on, and we'll support you in that. Whatever it is, whatever is an important problem.
Yep, exactly.
Bruce, thank you. Any follow on before we move on to the next person? Bruce, you good?
I'm good.
All right, very good. Outstanding. And Bonita Banducci.
Hi, thank you so much. I just had to chime in because my own work has been a focus on the collective intelligence that what women bring to the group for higher collective intelligence on problem solving, complex problem solving. That MIT and Carnegie Mellon did the research way back in 2010. And given the UN Women have declared that the Sustainable Development Goals will only be accomplished if we have 50-50 representation of men and women at every decision-making table. And I include the full dimension of gender myself. And I'm sure they do. I just had to chime in and say this is so exciting because to me, for complex problem solving, the UN Sustainable Development Goals covers a lot. And I've been planning to write a book myself and been engaged in conversations with several other authors, and I had come up with the idea of calling it Thinking Together. And it's just so amazing that this conversation is today, and to be able to draw in the technology. But what I'd really like to ask people is if you have examples, and David particularly, but everyone, if you have examples of the problems that have been solved through collective intelligence, through using Croquet, I would love to have examples to be able to demonstrate. And of course, I'd like to have diversity of all kinds, but I'm willing to just have some great examples. So I hope you'll be collecting them, David, in some way.
We will.
Okay.
Yeah, that's so essential. And by the way, I sort of think of it, the people who ignore, for whatever reason, women in this I mean, it's like ignoring half the power of humanity. It makes no sense. And I also say the other thing is diversity provides multiple points of view, which are absolutely required to be able to solve these complex problems. Alan is probably known for saying point of view is worth 80 IQ points. And having anyone with a very different perspective on the nature of what it even means to be human is so absolutely essential for us to be able to, not just solve the problem, but what even understanding what the problem is. And so, it's your point's really important. And all I have to say about Croquet is we just got into beta with this version. Earlier versions, I kind of have to say what I was never too happy with as true collective intelligence platforms. They didn't have the strengths that Doug's system had. This version was an attempt to directly address that, to build a system. And it really comes down to that one thing is being able to program inside the system is kind of the holy grail. And by programming, by the way, I don't mean just writing code like I showed you, but debugging the system. And you sort of think, well, that's not everything. But the reality is, if you can do that, then you can do everything else. The hardest thing in these systems is going to be actually collaboratively working together to figure out why the system you're using right now doesn't work, and being able to modify it and so that it does work in the way that's required. And also, I have to say that, and Doug knew this and Alan knew this, is that when you have a system that can extend the system itself, that's amazingly powerful. Unfortunately, people today are thinking, I'm going to build a ship in a bottle for like a metaverse app platform, and I'm going to put it into the ocean. And what happens with ships in the bottle that you throw in the ocean, they sink. Instead, what you have to do is build a raft with tools, and those tools allow you to modify the raft so that it becomes more capable based upon the environment that it's having to survive within, so that it turns itself into an aircraft carrier if that's necessary. I mean, that's the way you have to build systems. Systems have to allow you to use the system to extend the system, and that permeates Doug's vision. And of course, Smalltalk was built on that concept, which is one of the reasons it's still it defined the paradigm you're using of computing you're using right now. 50 years ago, if I sit you down in front of the of an Alto in 1974, you'd already know how to use it because you've been basically using its child ever since you switched from DOS. So that's power, and that's a power that's essential. Anyway, I went off topic, sorry.
Well, thank you very much. Thank you. I still get concerned because I'm working on a glass ceiling report from one of the big companies and with women in technology, and they're still finding that even women in positions are not being listened to. It's like, oh, they're scattered and all over the place instead of being seen as complex problem solvers and fire preventers. They're not focused enough. So anyway, I'm very interested to see how this plays out in Croquet and other environments. Thank you.
Thank you, Benita. Greatly appreciate you your contribution today. Richard, you had a comment in chat, and that'll be the last one for this session.
Can you hear me?
Yes.
Oh, what luck. I'm assuming this Richard you're talking about, but
yes, it is.
Yeah, okay. I'll go very fast and say that back in 1999, we had 8 computers set up in a conference room, all wired together, and people were editing the document in real time, and they were fascinated by it. So I do agree that close quarter sharing is really important. I was lucky enough to go to the 40th anniversary because of Malin's invite, and got to write a nice little cheesy article for Computer World. That was fun. I wrote a memo in 1997. Oh, sorry, I worked for the U.S. government. This is to Richard Ford. I worked for the U.S. government for my life, and I wrote a memo in 1997 saying, "Hey, I think this internet's going to be a big deal. We should fund it." That's that. And also in terms of building and trying again, I have heard Elvis did 56 takes of Hound Dog and used the 53rd take, so build on. And
Yeah.
finally, my actual question is, as a musician, I see great hope for being able to do real-time collaboration in music using these real-time tools. That was really cool, seeing the thing be able to move in sync. You know, that's always been the hang up. But that's it. I'll stop there very quickly.
Actually, the music side is really interesting to me. I have Alan Kay's Telecaster over here that that's my current axe. But the music's a really fascinating one, and actually I think quite doable today under certain circumstances. Latency is obviously always the problem there when you're doing it remotely. However, if you're kind of within a local area, I'll give you an example. Croquet right now, when I run it, I have about a 6 to 8 millisecond latency. So anybody who's around me has that we're at 6 to 8 milliseconds. When you look at 5G, it's not clear it's going to always work this way, but it looks like that's their goal. We should be seeing 5 to 15 millisecond latencies, which means that we should be able to play music together. And remember, to give you an idea how latencies convert, 1 foot is of sound is 1 millisecond, just about, plus or minus a little bit. So when you're 5 feet away, you're 5 milliseconds away. If you're 10 feet away, you can imagine I can play music with you if I'm 10 feet away. And in fact, orchestras, the reason I have a conductor is because that guy, this is from that guy is like 40 feet. So you need to have somebody. Yeah, I do think that as long as the participants are in a particular area, yeah, we should be able to see a rise of collaborative musical tools like this. And of course, if you're sitting right next to each other, then latency should drop to near nothing. And of course, that's kind of what people do anyway. But yeah, I find that a particularly interesting problem to solve, as does Alan, by the way. And we're both very intrigued by that. We think that there is a really interesting opportunity to directly address that.
All right, so David, the closing remarks are yours. I'm going to give you the floor for about 2 minutes to summarize, your entire universe that you're inventing. So time is yours. Jump in.
Yeah, so I talked about this augmented conversation. That took a while to really understand what this was and why we were doing it, and to kind of give it a name like that. And you can see all we're doing in a sense is repackaging Doug's ideas that were inherited by Alan, and Alan added his special sauce to it. Doug's vision, and by the way, it goes back to 62. If you read his paper from that time, it's extraordinary. It's like a blank piece of paper that he had, and he describes the universe not just the way we are today, but the way it really needs to be and will be. Hopefully, it's not 100 years from the time he initiated those ideas, but at least I think we and people like you understand what the problem is, but I also think we have an opportunity to hope for the solution space. What I've learned is that as soon as one example exists that addresses a problem, typically you'll find many others, but you have to have something that works end to end, that people can say, okay, I understand it now, I can do it now. And so many times your task isn't to build the system, but to demonstrate the system can be built. I'm hoping we're more than that, because I think what we built is pretty damn good. But the more important thing is that, as I said, we need to be back on track to where Doug imagined the world needed to be. And I think we're getting close.
Well, thanks for bringing us a few more meters closer to what was being envisioned. David, gratitude from the PCI community for being with us today.
Thank you.
We will make this recording available to you and others. So thank you so much. And maybe we can check in with you a year or so out to see what kind of progress you're making. How's that sound?
Good. I would love that. I appreciate it.
All right, everyone. Have a great week ahead. Looking forward to seeing you in 2 weeks on our next PCI community call. Cheers.
Bye now.